In this video, we'll write the balanced net ionic equation for NaOH plus MgBr2, sodium hydroxide plus magnesium bromide. The first thing we need to do is balance the molecular equation. So I can see that I have a hydroxide group here, actually two of them, and only one over here. So I'm going to put a 2 in front of the sodium hydroxide. Now I have two sodium atoms, just one here. If I put a 2 here, that balances the sodiums. Now I have two bromine atoms, but that's good. I have 2 here. Magnesiums, they're the same on both sides. The molecular equation is balanced. Now, for our net ionic equation, we need to write the states for each substance. So when I look at sodium hydroxide, this is a strong base. That means it's a strong electrolyte. It's going to split apart into its ions, dissociate. We're aqueous. Bromides, very soluble. Put aqueous. We have another sodium bromide here. Sodium compounds are also soluble. And then magnesium hydroxide. Magnesium hydroxide dissociates very little in water. In fact, if we look at a solubility chart, we find magnesium and then across the top hydroxide. And we go over, we see that it's insoluble in water. Because it's insoluble in water, it won't dissolve. So we're going to write a little S for solid. A very small amount will dissolve, but for our purposes, we consider it to be a solid. When these two substances react, we get a solid. It's a precipitate. It falls to the bottom of the test tube. So we have the states. Now we can split the strong electrolytes into their ions for the complete ionic equation. Sodium is in group 1 on the periodic table, has a 1 plus ionic charge. The whole hydroxide here, always 1 minus. So I have 2 sodium ions, and I won't write the states right now. Let's do that at the end. Plus 2 goes to everything here, so I have 2 hydroxides, 2 OH minus. Magnesium group 2 on the periodic table, 2 plus, the bromide ions always 1 minus. So I have the magnesium ion, Mg2 plus I have 2 of those bromide ions, 2 Br minus. So those are the reactants in our net ionic equation. For the products, we have 2 sodium ions again, and then 2 bromide ions. In net ionic equations, we don't split solids apart. So we're just going to keep this MgOH2, magnesium hydroxide. And that gives us our complete ionic equation. Now we can cross out the spectator ions. They're on both sides of that complete ionic equation. They haven't changed, so we're not interested in them. I can see in the reactants here I have 2 sodium ions, and in the products I have 2 sodium ions. Let's get rid of those. 2 bromide ions, products, 2 bromide ions. They're gone. And what's left is the net ionic equation for NaOH plus MgBr2. I'll clean it up and write the states in. We'll have our net ionic equation. And this is the balanced net ionic equation for NaOH plus MgBr2. You can see charges conserved. I have 2 negative charges, 2 positive. They balance out. We have a neutral product. And if you count the atoms up, they'll be the same on both sides. One last thing, often you'll see the positive ion first and then the negative ion written second. It's the same net ionic equation. This just kind of looks nicer. This is Dr. B with the balanced net ionic equation for sodium hydroxide plus magnesium bromide. Thanks for watching.